Okay, welcome to my presentations. I wanted to say good morning, ladies and gentlemen. Now we have only gentlemen. Okay. So welcome to my presentation. It's about the Riegl VZ2000i, next step in mine surveying by workflow automatization and customization. I hope you had already in the past some experience with 3D laser scanners because I want to focus today on the brand new features of this scanner. I want to speak about the key facts of that scanner. I want to speak about also the hardware and the firmware architecture. Thereafter, I want to focus on the onboard real-time post-processing task because this is really a game changer in using terrestrial laser scanning. It's speeding up the data acquisition and the post-processing. And I will end with showing you some examples how you can customize with special applications, apps, your scanner according to your demands. Here you see our classical V-line scanners and also the time when we introduced them. So the VZ400 started in 2008, the VZ6000 in 2012. They are ranging over from 600 meters up to 6 kilometers range. And during the life cycle of the VZ400, we have done a lot of hardware improvements, which you can see here on the top, and also firmware improvements. And all these improvements lead finally to the brand new scanner, the VZ400i, which you see on the left side, and the VZ2000i, which we just introduced last year in autumn to the market. You see here the key specifications. So we have a pulse repetition rate of 1.2 megahertz, which means an effective measurement rate of 500,000 measurements per second. And this in combination with an extreme long range of 2.5 kilometers. But this brings us into another problem. We call it the MTA problem, or the multiple time around capability. This is a so-called, we are measuring with the speed of light. We are sending a laser pulse, which is reflected by the surface, and we are measuring the time between emitting the pulse and getting the reflection. So that's a time of flight measurement system. But we're running in that problem that the speed of light is too slow for us. We are measuring with such a high measurement rate on long ranges that we have multiple laser pulses in the atmosphere. With the older scanners, it was always one laser pulse sent, then the reflection back, and then we sent the next laser pulse. But now with 500,000 measurements on long range, we cannot wait till the reflection comes back. We have to already send the second pulse. So we have now up to 5 laser pulses in the air, and finally the reflections are coming back to the scanner. And how should the scanner now detect from which emitted pulse comes this reflection? So this is a very tricky thing. We have developed a special algorithm. We have a patent on that. So Riegl is the only manufacturer who can handle high measurement rates on long ranges. And that's a big benefit for you because it's increasing the acquisition time. Next is the new thing is cloud connectivity on that scanner. You can integrate a SIM card like from your mobile phone, then the scanner is online in the internet. You can directly upload the data into the cloud, or you have also the option to remote control the scanner from any point of the world via the internet. I will show you that later. And one of the most important things is we have data processing capability on the scanner already. So many steps which you have done up to now with the terrestrial laser scanner on the computer in post-processing are done now directly on the scanner in real time. So let us speak about this additional processing power. So if you have a look on the processing power of a classical V-line scanner, single core processor, Now with the new scanner we have a dual core processor around 4 times faster. But this is only half the story. We have an additional processing board 10 times, oops, 10 times faster than this dual core processor. So this is a real computer inside the scanner. And this computer is handled then the post-processing tasks directly in the field. Here you can see how we divide the work for the scanner. The dual core processor on the left side. This is only responsible for the, we call it the LiDAR engine. It's performing the scanning, it's doing the so-called echo digitization, the online waveform processing, which means extracting of the target information, putting the data attributes on the data, and finally storing the raw data on the scanner. The second board is responsible for all the other interfaces, for the graphical user interface on the scanner, for the additional sensors on the scanner, like a camera on the scanner, a GNSS receiver, an integrated IMU, which gives us roll, pitch, and yaw, the orientation of the scanner. So this processing board is managing all these interfaces and again executing post-processing tasks. So I have now spoken a lot of times already about these post-processing tasks. Now I want to list some of the tasks so that you get a better understanding what we do already in real time in the field. First of all, we run the so-called RDB library, which takes the raw data and creates a real 3D point cloud, spatial sorted with a level of detail, which means it's a database structure and it enables us to visualize large point clouds directly on the tablet and on remote clients via low bandwidth connection, directly in real time. So once we have this 3D point cloud, as I have told you before, we have to solve the range ambiguities, and if you have a look on this sketch, you see you get data with high reflectance on long ranges. We have here MTA zone 5, so we have 5 pulses at the same time in the air. And you see here an example with just 2 MTA zones. If you don't correct it, the data looks like that. But with our special algorithm, we can assign the data into the correct MTA zone and having then a correct 3D point cloud already in real time on the scanner. And we need that correct point cloud because now comes the most important post-processing step, registration. We have to register different scan positions into one coordinate system. And this we do in multiple steps. First step is, you see the data here unregistered. First step is using the built-in sensors like GPS, IMU, and compass sensor to get a rough orientation. And in the next step, we have a software solution on the scanner, finding features in the overlapping areas and aligning them with a best fit alignment so that we have millimeter accuracy between the different scan positions, shown here on the right side. We see this in a typical mining example. You see here the settings on the scanner where you simply on the graphical interface enable the automatic registration and just set typical environment definitions so that the scanner knows better how to extract the features. So this is a typical mining example. So we selected that option here. And then based on the overlaps and the internal sensors, we get the rough orientation and position. Thereafter, we extract so-called voxels, what you can see here. It's like a Lego landscape, and the software fits these voxels from the different scan positions together. And finally, the fine alignment is done by extracting plane patches and fitting the plane patches from different scan positions together to get finally really high accurate data. And you get as a result this 3D planes showing the standard deviation of all the data, which gives you directly a good report how accurate your data is registered. And now let's speak about the benefits of this onboard registration. Why we are doing that? We can do it also in the office afterwards. But I mentioned already, we have the cloud storage possibility. So we can directly store all the data on the cloud in real time, which means the data is directly available for further analysis, like monitoring, autonomous machine control, volume calculation, blast planning, etc., etc. Once we have the registered point cloud, next step is you want to have it in your mining coordinate system, because by default the GNSS receiver delivers WGS84 coordinates. For that we have a so-called GeoSys manager, which is using the online EPSG database, where you can get all the ellipsoid information, datum transformation information, projection, coordinate reference systems. So all these things you define once on the scanner, and then you can import and export your data in any well-defined coordinate reference system. You see this here as an example. The scanner delivers WGS84, and you have directly in this example UTM zone 33 north available. But again, you see you can define any coordinate reference system with ellipsoids, datum transformation, geoid models, map projections, coordinate reference system. So all this is done once, and then you can forget it, and you always get your data correctly in your mining coordinate system. And finally, I told you already, we can customize the scanner with apps. So I'll show you now the pre-installed apps and highlighted the apps which we have mentioned and which I will further mention in this presentation. So we have a simple file browser for data transfer between the internal hard drive and the SD and USB stick. We have the upload tool for uploading data into the cloud. You have already seen in one of the slides before. A very important app is the remote control app. I will show you on the next slides. Then we have a task app just listing and showing the process of task running in the background on this additional processing board. We have the registration tool for the onboard automatic registration. You have seen that already. Further on, we have a very powerful scheduler app for scheduling the scans for different areas, for different times. I want to show this also on the next slides. And then we have a simple timer function and an app to create screenshots of the graphical user interface. That's not so important. So, remote scanner control. Just to show you how you activate it, you click on the button, you start the VNC viewer, and you see here on the bottom we have two options, local access and remote access. By activating the local access, we just use the integrated wireless LAN, and thereafter you can connect any tablet, any iOS or Android or Windows system, just like in the hotel with a hotspot. And there you start then our free app, which is available on the app stores, and you can fully remotely control the scanner via this wireless LAN. The idea is, for example, many customers of us are mounting the scanner on a vehicle in the mine, sitting inside the car, running on an iPad, for example, this app to control the scanner, and then they do stop and go scanning. Each scan approximately 40 seconds, then drive another 30 meters, stop the vehicle, scan, and you can do it also around these big machines. Nobody has to go out of the car now. So you stay in the car, you are safe, and again you can upload directly the data into the office, and somebody else in the office can already do standard surveying as before in the field directly on the 3D point cloud. The other option is to have a fully remote control via the internet. For this, we activate the mobile network on the scanner. You have thereafter 4G network connection if there is a mobile network, of course. And then the scanner is in the internet available, and you then start the remote app with the remote access. And in that example, we have a customer from De Beers in Canada. They have their headquarters in Calgary, and they're operating mines in the Northwest Territories and in the northern part of Ontario. Here an example, fully autonomous installation, and they can control the scanner directly from the headquarters. And keep in mind, also upload the data into the cloud and having the data directly available. This is the app, which is, as mentioned before, already available on Windows, Apple, and Android platforms. And you simply have then exactly the same graphical interface as on the screen of the scanner. Further on, the scheduler app, that's a very interesting tool and easy to use. Here I show you the whole app is a simple Python script. And I just want to mention, every programmer who is able to do Python scripting and C++ programming can develop his own app for the scanner. So that's a fully open structure. You can customize the scanner to your demands. And for scheduling, we simply need a configuration file. And now I show you how to use that configuration file. Let us assume we want to scan different parts of the mine with different schedules, with different scan patterns. So we have, let's say here, 3 different zones. And we are using standard so-called cron scripts. Cron scripts are used normally for scheduling Linux tasks. And as the scanner is a Linux system, we can also use that. And you can read further details about cron scripts also in Wikipedia. It's a simple syntax. You just have 5 entries for the minute, for the hour, for the day of the month, for month and day of the week. So if you want to perform a scan, let's say every 10 minutes, you just type in schedule equal to star divided by 10 every 10 minutes, and the other 4 stars you just leave. So that performs a scan every 10 minutes. But you can perform very complex schedules. For example, you want to do a scan every half an hour during the day shift between 8 and 7 o'clock in the evening on every weekday from Monday to Friday. Then you just type in schedule 15:45 for the minutes, then between 8 and 18 o'clock, the next we leave, and then for the day of the week 1 to 5 means from Monday to Friday. So that's a very complex schedule. And let's say the last area, you just want to scan once a year, for example. Then you just type in schedule 00. It will be scanned at midnight. The third entry we don't need. And the fourth is then the month, November, and the last one, day of the week, Friday, number 3, every third Friday in November. And all these schedules you just write into a simple text file. So the header of the text file is the default setting for a project, a scan pattern measurement program, and if you want to acquire images or create every scan a new scan position. Thereafter it's followed by job 01 with the schedule, then job 02 with the schedule, and if you don't want to use the default setting, you just define your own settings here. So you can change the measurement program and using a different scan pattern, because of course for that area you want to have a different resolution and a different field of view. And then job 3 you can even change to a different project name and again with a different scan pattern. And you simply copy that configuration file onto the scanner, start the scanner, and it will automatically follow this schedule. So, just summarizing what you have seen during this presentation, all our onboard tasks. First, we create with the RDB library the point cloud. Then we are solving the range ambiguities, the MTA processing. We have the registration module to combine the scan data into one project coordinate system. Thereafter, the GeoSys manager to transform it into any coordinate reference system. And finally, and I think that's one of the most important things, you have the possibility to customize the scanner according to your demands. But of course, one thing in the end, you can still use the scanner like in old days, by default on the machines, but I just wanted to show you today all the new possibilities for the future, because we simply know the trend in mining goes into a remote controlled, autonomous running, open pit mine anywhere in the world far away from the people. And such a scanner can deliver base data for such a mine. Thank you. And I'm available on booth number 241, also in the afternoon for further questions. Thank you.